Hello and welcome to your Unit 5 Quiz Review Google Classroom packet. A couple things before we get started. First is that this packet will count for a grade. It will count for an academic habits grade. I don't know why I put that in parentheses, but whatever. It'll count as an academic habits grade. Everything that shows up in this review packet will show up on your quiz that you're going to take in about 45 minutes. So I strongly suggest you take this seriously. When you are finished with this, you will get to take your quiz. I will grade them over the weekend, and then we will have correction time potentially on Tuesday after college signing day. So this is the Google Classroom section. I'm going to do these 3 problems. This is the you try or the pause and practice section. Okay, so looking at this one first, this says given an angle measure, we need to find sine of 315 is equal to x. Let me zoom in on this a little bit. Okay, so given an angle measure, what we need to find is the coordinate point. Okay, and remember that when we're talking about sine and cosine, cosine are always x values and sine are always y values. So if I'm looking at this sine of 315 equals x, what this is really asking me is, what is the x value? So, sorry, y is sine. What is the y value? Man, I already messed up and we're like a minute in. Okay, what is the y value, because we're talking about sine, at 315 degrees? Okay, so I'm going to look at my unit circle. Handy unit circle here. Notice it says please do not write on if you're using one of the class set ones. And I go around my unit circle till I find 315. My y value at 315 is negative square root of 2 over 2. So that means my final answer is negative square root of 2 over 2. Okay, so this one is just can you read the unit circle? Okay, next one is given a coordinate point when x is between 0 and 2 pi. So this just means one rotation around the circle. So we only have to go around the circle once. Okay? What this is asking me, because now the x is next to sine, is what degree measure has a y value, because again we're talking about sine, of 1. Okay, so what degree measure has a y value of 1? Okay, if I'm looking over at this, I'm going to scan through all of my y values. I see a y value of 1 here, so I know 90 degrees. So I know x is equal to 90. I'm going to scan, see if I see anything else. I don't see any other places where y is equal to 90, but that won't always be the case. So for example, if this question instead was cosine of x is equal to 1, okay, so say that this is a new question, cosine of x is equal to 1, then I'm looking for our cosine of x. Let's make it cosine of x is equal to 0. Okay, if I'm making it cosine x is equal to 0, that means I'm looking for x values of 0. If I'm looking at my unit circle, I see 2 places where I have an x value of 0, at 90 and at 270. So I would have 2 answers here, x equals 90 and 270, because there is more than one location on my unit circle that has an x value of 0. So just be careful of those double answers as well. Okay, last thing that we're going to look at is if we're ever given tangent. Reminder that tangent, we can rewrite it as a trig identity as sine over cosine, which is just our y values over our x values. So we have to do a little simplification here. So this says tangent of 240. What that really means is the sine of 240 over the cosine of 240. Okay, another way of saying that is the y value at 240, because one more time, sine is always y, cosine is always x, over the x value at 240. Okay, so let's look for those values. I'm going to go around my unit circle till I get to 240. My y value at 240 is negative 3 over 2, negative square root of 3 over 2, so negative square root of 3 over 2. That's my y value at 240. My x value at 240 is negative 1 over 2. So negative 1 over 2. Okay? When I'm dividing a fraction by another fraction, I do same change flip. My first fraction, negative square root of 3 over 2, stays the same. Division changes to multiplication. And my second fraction flips. So my second fraction becomes 2 over negative 1. Then I look for anything that I can cancel. I'll try to grab another color here. Look for anything that I can cancel. So I've got a 2 on the top of the fraction and a 2 on the bottom. So those should cancel. I'm going to go ahead and combine these though. If you multiply fractions, you multiply across. You can go ahead and cancel the 2's here if you want to. But I find it easier to write this as negative 2 over square root of 3. And then over negative 2. To me, it's then easier to see, oh, there's a 2 on the top and a 2 on the bottom. Those 2's would cancel out. My final answer is square root of 3 over 1. Okay, so tangent is exactly the same thing. You're looking for your x and y values at a specific degree measure, but it gets a little tricky with our same change flip when we're dividing a fraction within a fraction. Okay, that is it for this section. You are going to pause the video and practice these 9 problems at the bottom. When you are finished with these 9 problems, move on to this next section of the video, which is looking at function attributes. Okay, so 2 things we have here. We've got the sine graph and the cosine graph. What we're going to do first, I'm going to do the sine graph, plot the points, and talk about the attributes. Then you're going to do the same with the cosine graph. So we know that sine is always equal to our y values. Okay, our 5 easiest points to plot are at 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's every 90 degrees or every fourth of the circle. So let's look at those. I'm looking for at 0 degrees, what is my y value? At 0 degrees, my y value is 0. So I'm going to plot the point 0, 0. At pi over 2 radians, okay, at pi over 2 radians, my y value is 1. So I'm going to plot pi over 2 radians. I'm going to plot this at 1. My scale here is 0, 1, 2, 3, 4. Should have written that in before. Okay. Then at pi radians, I go over to pi. At pi radians, my y value is 0. So I plot at pi 0. At 3 pi over 2 radians, my y value is negative 1. So at 3 pi over 2 radians, my y value is negative 1. And then at 2 pi radians, that is 1 full rotation around the circle. So at 2 pi radians, my y value is 0. So I'm going to plot that right here and go ahead and connect my points, even though I kind of missed that one. Sorry about that. Okay, when we're talking about domain, we can put arrows on the end of this function because we're assuming it continues forever and ever and ever in both directions. So domain is going to be negative infinity to positive infinity, or all real numbers. The range of this function, well, I have a maximum point and a minimum point. The range of this function cannot go outside of those. Range is y values. My function fits within kind of this interval of y values. So my range is going to be from negative 1 to positive 1. Okay? The first, if I put a pen or a piece of paper, the first y value that I hit when moving up the function is negative 1. The last y value on my graph is at positive 1. My maximum value, I have multiple maximum values, but every maximum value occurs when y is equal to positive 1. Every minimum value occurs when y is equal to negative 1. Those are the values that help me make up my range, my maximum and minimum value. My y-intercept is where the function touches or crosses the y-axis. My y-intercept here is at 0, 0. My x-intercepts, well, I have multiple of them, right? I have one here, I have another one here, I have another one in a another certain interval, which is where our x-intercepts come from. My x-intercepts start at 0 and repeat, or occur is a better word, occur every 180 degrees or pi radians. So from 0 to pi, that's where my first x-intercept occurs. From pi to 2 pi, that's where my second x-intercept occurs. The amplitude of the function is the distance from the maximum point to the x-axis or from the minimum point to the x-axis. So my amplitude here is 1. It's also my amplitude here. It should be the same distance from the x-axis to the minimum, from the x-axis to the maximum. So my amplitude here is equal to 1. Another way that you can find the amplitude that we haven't really talked about is you can take the y value of the maximum point and then the y value of the minimum point. So my y value here is positive 1, and then my amplitude here is also 1. Okay, so I could do 1 plus 1 and then divide that distance by 2 because I'm looking for the average of that. So I could do 1 plus 1 is 2 over 2 equals 1. So you can also take your maximum y value plus the absolute value of your minimum y value, divide it by 2 to find your amplitude as well. We haven't talked about that as much because we've only talked about the parent functions, but that is another way to find your amplitude. And last but not least is our period. The period of the function is how long it takes for the function to repeat itself. Sine and cosine functions are very much like circles. A circle takes 360 degrees or 2 pi radians to repeat itself. Sine and cosine functions do the same. The period is 360 degrees or 2 pi radians. It's how long it takes for the function to complete itself, or to repeat itself, excuse me. Alrighty, your goal next is to graph the cosine function. Remember here, cosine is x values. Then find the domain, range, maximum, minimum, y-intercepts, x-intercepts, amplitude, and period. So this is your pause and practice here. When you are finished, we'll look at function transformations, and we will look at how to graph those. Okay, we did this on a Google Classroom activity last class. Couple things here. Let's start with your a value. I'm going to tell you how each of these shift the function. For your a value, okay, when the absolute value of a is greater than 1, your function will, the amplitude of your function increases. If a is between 0 and 1, so if it is a decimal, your amplitude decreases. And if a is negative, your function reflects across the x-axis. Okay. Next one we are going to look at is b. Okay. I'll draw it down here. For b, okay, if b is greater than 1, your function will get narrower, so it'll get compressed. If b is between 0 and 1, so again, if it is a decimal like 0.5, 0.7, 0.8, whatever, it will get wider or stretched. S-T-R-E-T-C-H-E-D, maybe? Is that how you spell the word stretched? Who's to say? Okay, last ones we're going to look at. Inside the parentheses, notice that this c is inside the parentheses. When c is negative, the function will shift right. When c is positive, the function will shift left. And finally for d, which is outside the parentheses, so c is inside the parentheses, D is outside the parentheses. If D is negative, the function will shift down. And if D is positive, the function will shift up. Okay, so this is very, very similar to function transformations we've seen in the past. Now we're just working with sine and cosine functions. So we're going to graph one of them together so you can see how to do this without a calculator. And then, yeah, that's pretty much it. You'll have practice time and then whoop-de-doo quiz time. Okay? First thing here, it says sketch the graph of the parent function in one color and the graph of the transformed function in another. No calculator. If you don't have different colors, that's fine. You can do solid lines versus dotted lines. That's easier for you. But I do have different colors, so I'm going to make them in different colors. Okay? So first thing we're going to look at is our sine function. From the graph before, I showed you the quick 5 points that you can plot sine. If you forget them, just always remember that sine is your y values. You can go back to your unit circle to find those. But the quick 5 points, we start at 0, 1, 0, -1, 0, and we can go up to +1. Okay, so this is my parent function. This is the function in its most basic form. Okay, what I want to do next is look at what transformation is shown. If I see a +2 on the outside of the parentheses, if I see a +2 on the outside of the parentheses, that means up 2 units. Okay, so I'm going to look at every single point on my graph, and I'm going to shift it up 2 units. So I'll start with this one. We went up 2 units. This one, 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 up 2 units. And this one, up 2 units. So when I connect those together, I can see how the entire function shifted 2 units up. Okay, I will start you off on this one because I know we had some confusion over a very similar one last class. First, your parent function here is cosine. Cosine starts with a y-intercept of 1. Remember, cosine is your x values. Okay, so I'm going to plot these, the parent function, super quick. Okay, so this is what my cosine function looks like, somewhat, if I could draw through the points correctly. This one is your a value. So this changes the amplitude of the function. This changes the amplitude of the function. My new amplitude of the function should be 3. So that means all the values that are going to change are my max and minimum values will go to 3. My x-intercepts will stay the same. My x-intercepts will stay the same. So if I look at this, this is a maximum value, so I'm going to move it up to 3. This is an x-intercept, so I leave it alone. This is a minimum value, so I move it to -3. This is an x-intercept, I leave it alone. This is a maximum value, I bump it up to 3. This is an x-intercept, I leave it alone. So when I connect this function together, I go through the same x-intercepts, but my maximum and minimum values have changed because my amplitude has changed. So if you get something that's changing the amplitude, just shift your maximum and minimum values. All right, y'all, that is all I have. You've got 4 more sketched functions here. 1, 2, 3, 4 more. You need to finish these, and then you will be ready for your quiz. That's all I've got. Have a lovely rest of your day. Like and subscribe.